Hey all, so we're going to look at day two, which is probabilities with and or statements. So it's the probability basically of two events occurring. It could be more than two, but we're going to look at two for today. So first we're going to look at what does it mean if you have probability with and, of the probability of two things happening, like probability of rolling a die and getting a two, and flipping a coin and getting heads. Well, rolling a die and flipping a coin are what we call independent events. So two events are said to be independent if the result of the second event is not affected by the result of the first event. The probability of one event does not change the probability of the other. These events are independent, as opposed to dependent events, which we'll talk about in a little bit. So if A and B are independent events, the probability of both events occurring is the product of the probabilities. So if A and B are independent, and only if they're independent, so you got to decide that first, then the probability of A and B in this notation here, I'm going to add a little note, means and. The probability of A and B is the probability of A times the probability of B. So for example, what is the probability of tossing a coin and getting heads and choosing an ace from a deck of cards? Well, the probability, we write this as such, the probability of getting heads and an ace, well, the probability of getting heads is 1/2. The probability of getting an ace is there are 4 aces out of 52 cards. So you get 4 over 104. And if you want to simplify that, we could. 4 out of 104, 0.0385. By the way, we didn't talk about this, but rounding, when you round for probabilities, I like to go 4 numbers at least. 0.0385, right? And why is that? Because when you convert to a percent by moving over twice to the right, it rounds to the hundredths place in a percent, which I think is accurate. Okay. Next up, a drawer contains 3 red paper clips, 4 green paper clips, 5 blue paper clips. Right? So first off, that's 9, 10, 11, 12. N, your sample size, there are 12 total paper clips. One paper clip is taken from the drawer and then replaced. Another paper clip is then taken. What is the probability that the first paper clip is red and the second is blue? So we're looking for the probability, red, and blue. And remember, this is with replacement, so these are independent events because the probability of each event does not affect the other. So we have, let's see, red first and then blue, so 3 out of 12 times 5 out of 12 will give you 15 out of 144, 0.1042. So about a 10.4% chance of this happening. Now, what about dependent events? Dependent events is when one event happens, it changes the probability of a different event, okay? So the probability for dependent events says if A and B are dependent and A occurs first, then the probability of A and B is the probability of A times the probability of B given A has occurred. And we write that as such. The probability of A and B for dependent events is the probability of event A times the probability of event B given A has happened. So what this means, and we can write a little definition here, is the probability of B given A has happened. So for example, and you see this a lot with marbles, a bag containing 3 green marbles, 2 red marbles, a marble is drawn, not replaced, and then a second marble is drawn. What is the probability of getting a green and then a red? Okay, so we're looking for, let's see, the probability of green and red. So this is going to be the probability of green times the probability of red given that a green has happened. So let's see, what's the probability of getting a green marble? 3 out of 5. Then the green marble is taken out. Now there's only 4 marbles left. And what's the probability of getting red now that green has been taken? 2 out of 4, which is 6 out of 20, which is 0.3. Number 4, a drawer contains 3 red, 4 green, and 5 blue paper clips. One paper clip is taken from the drawer, not replaced, so it's dependent probability. What is the, and then another probability is, paper clip is taken. What is the probability that the first is red and the second is blue? So the probability of red and blue, and this will be the probability of red times the probability of blue given red was taken. So 3 out of 12 red times out of 11, 5 out of 11, which is 15 over 132, which you could leave it that way. You don't have to change this, but I like to see it as a proportion. 0.1136, about 11.36%. Good. Now, the probability of or statements. We have a formula here, the probability of or, and we write the probability of A or B equals the probability of event A plus the probability of event B minus the probability of A and B. And why is that? Because if you're counting when it happens in event A and when it happens in event B, sometimes you might be counting it twice, whatever the event is. So therefore, you have to subtract when you counted it twice. So for example, a die is rolled. Remember, there's 6 numbers on a die. What is the probability? The number is even or less than 4. Okay, now be careful here because watch, what are the even numbers on a die? 2, 4, and 6. So this is 3 out of 6. What numbers are less than 4? 3, 2, and 1, which is 3 out of 6. But how many numbers did we count twice? We counted 2 in both groups. So you counted 2 actually twice, right? Because if you just added these together, if you said that's the probability of even plus the probability of less than 4, you would get, if you just did that, you would get 3 over 6 plus 3 over 6, and then you would be saying it's 6 over 6 or 100%, but that's definitely not true, because what if you get a 5? That's not less than 4, and it's not even. So, let's see. Minus the probability of even and less than 4. Well, how many numbers are even and less than 4? That's just going to be 2. So that's minus 1 over 6, and you get 5 over 6. Okay, let's look at one more. Number 6, at Andrew Jackson High School, students are only allowed to enroll in AP US History if they have already taken AP World History or European History. Out of 825 seniors, 165 took World, sorry. Probably they took World. 165 out of 825. 66 took AP European. Probably they took Euro. 66 out of 825. And 33 took both. Probability they took World and Euro. 33 out of 825. Given this information, determine the probability a random selected senior is allowed to take U.S. history. Again, who's allowed to take U.S. history? If they have taken AP World or AP Euro. So we're looking for the probability that they took World or Euro. Well, what I like to do is I just like to put A and B. And then you just say this, it's the probability of A plus the probability of B minus the probability of A and B. It just makes things a little quicker. So what's the probability of taking World? 165 out of 825. Probability of taking B Euro? 66 out of 825. What's the probability they took both? 33 kids took both, right? So don't count the 33 kids that took both twice, so we have to subtract it. And then we do 165 plus 66 minus 33 is 198. So the probability they took World or Euro, 198 out of 825. 198 out of 825. It's about 0.24, 24%. Okay?